Assistant professor at Paris University. In France, an assistant professor is someone that do half of the teaching and half of the research. I am a developer on some known and unknown open source project. I think the OpenJDK is well known. You may know Aliasing, which is a library to generate bytecode. I'm one of the two developers of that library, and some other projects that people don't use at all, like T2 and Pro. Pro is the best build tool because it's mine. I have done my PhD thesis on method call in dynamically typed language. I end up being one of the guys that create invoke dynamic. Basically, at the end, we were three people, and you have two of them in this conference. The other one is Dan Hedinga. I don't know if he's here, but he has a talk, I think after lunch, about another modification, which is constant dynamic, which was introduced in Java 11. So I have participated in the group that have created lambdas, module, records that will be in Java 14. And I will talk about Valhalla that will be in Java 122. So I'm not an Oracle employee, but Java is open source since a long time. You can add what you want in Java. You just have to convince the other people. And it's easy, you have a lot of open mailing list, and you just join the mailing list and make your point. So yeah, basically I have started at the time, I have started to add things to Java at the time Java become open source, a little bit earlier. By example, if you use a constructor of string that take a card set as parameter, it's my code. Don't believe what I'm saying. I mean by that, don't think, don't create a product on what I will show you. Because what I'm showing here is my current state of mind. It will change. We will have more meetings. So please, please, please don't think what I'm saying is gold and will be always the same after. We never change. So the Valhalla open project starts, I think, 6 years ago, and we still have no result. Almost. I will explain why, but we spend a lot of time evaluating technology before starting, and now we are confident that we are almost knowing what we are doing. So, Java at its inception, remember in 1993, if you were not in diapers at that time. So this is my first computer, not my first, it's the first computer I have bought with my own money. A lot of money at that time. So at that time, basically doing the dereference of a pointer and doing an addition was roughly the same cost. So at that time, it makes sense to have any object in Java to be held by reference, because basically it simplifies the model. If you come to C, where you can have stack allocation, malloc allocation, global allocation, and so on, The model of Java was far, far, far simpler. The main issue is this laptop, and in this laptop doing a pointer dereference, if it's the worst case, if you have a cache miss on all the caches, it's roughly 300 additions. So the cost for the CPU are not the same. Obviously, the platform has evolved. We have JITs now since a long time. We have some JIT optimization like escape analysis. But the escape analysis works only if the JIT is able to prove that you don't use the identity of an object. The escape analysis is the optimization that will try to remove the allocation, so you will not do pointer dereference. Basically, this is an array of complex, so I have a complex class with a real part and an imaginary part, and this is the layout in memory of such arrays. As you can see, you have a lot of memory used by the header of each object, and each object is handled by a pointer. What we want to introduce is to try to have a new kind of class, what we call inline class. What an inline object is an object where you say, I don't care about its identity, so no pointer. I don't need pointer for it. But because there is no pointer, it cannot be null. No pointer, not null. And the runtime model is this one. The idea is if you use it on the stack, it will go in register directly. So you will write new, but there will be no new, in fact. And the runtime model on the heap is instead of having a pointer, you will take the value and put it inside the object that contains the inline object. So for an array of complex, if complex is an inline class, you will have this structure in memory. No headers, no pointers. Basically, the object is able to inline itself into another class or another array. So it's like C-struct. In C, you have an array of struct is not an array of pointer, it's an array of struct. And like in C, if you do the allocation on stack, the compiler will try to scalarize it and not storing on the stack, but directly on register if the inlining works. But there is an issue with the C and C++ model, which is if you take reference to the stack as parameter, and when you change a field, for the compiler, you don't know if it will impact the field of the other parameter. So basically, C is slow because of this. There is a lot of optimization that you cannot do because of this aliasing issue. We don't have it in Java. We don't want to introduce it in Java. So the solution is to make the inline class immutable. If you make the inline class immutable, from the JIT perspective, there is no aliasing which is possible. And the VM is free to allocate the object or not. The user will not see if it's allocated or not on stack. So an inline object is not mutable too. This is the model we want to implement. It's as simple as this. So why it takes so much time? Before going that way, I want to show some example. So the first one is inline is not a guarantee. The VM may decide to not inline at runtime. Because you can have an inline class that contains an inline class that contains an inline class and so on, so have a very big object. So in that case, it doesn't make sense to pass it by value. It's better to pass it using a pointer. So the VM can decide that for a class or for an array of class to still use pointers. For arrays is if you have an inline class which is big enough, and if you have a big arrays, you will end up with a lot of memories. So basically, for the model, an inline class is inlineable. You are saying to the VM, you can inline it, and not you will inline it. So for volatile fields, by example, you don't want to inline it because a volatile field has to be atomic when you write in it, and if the object is too big, the CPU is not able to write it in one instruction. And currently on hotspot, static fields are not inlined too. It's a kind of bug of hotspot. I will show you why. But currently static fields are not inlined. But it's a bug of the current hotspot implementation. Maybe in the future it will change. So some examples, how you declare an inlining class. An inline class, it's very easy. You just put inline in front of it and you have an inline class. What's the model? So you add inline. You cannot have superclasses. You can implement every interfaces you want. All fields are final. It's immutable, and you can add any method you want. Any methods you want. So just a small example. I don't care about the math, but I like drawing Mandelbrot image. If I write this code currently in Java, it will create a lot of objects. And if I do a benchmark using GMH, I will have this kind of performance. So I compare 3 different code. The one where by end I have take my complex class and basically inline by end the things. What I call indirect is a classical class. So if I remove the inline keyword in front of it, and the one with inline is with an inline class. As you can see, you will have to trust because I have run the GMH on slide. So you will have to trust me, or you will have a presentation at which time is it? Okay, after lunch. A presentation about the real cost of how the inline class works. So basically, we have exactly the same performance if you do it by yourself by hand, or if you do it by just putting inline in front of it. Another example, this is Java long integer written as an inline. I call it int box, but it's exactly the same thing. So I can have a field, I have constructor, I have method, can I have static methods. Now, because it's an inline class, you have to think that the new inbox 0 here is not a new. Everyone see? It's not a new. You will get value with 0 in it. No heap allocation. If I take an array of int box, I initialize it with some values, and I just sum all the values of the array. Again, I will do this with an array of int box, and an array of integer, and I will get this result. Basically, an array of int or an array of the inline class corresponding to an int have the same performance. Yeah. You can see the cost of a Java long integer is not that bad, as you can see. It's only twice slower, but it's not really twice slower. GMH doesn't measure the GC things. It's a trick in Java. The allocation is really fast, and the GC is not that fast. But when you measure only the performance, it's fast. The other thing is, what if I shuffle the array? Obviously, I will get exactly the same result, but the performance of an integer will be slower. Why? No. CPU unoptimization. If you shuffle your array of pointer, you will have pointers that point everywhere in memory. If you don't shuffle it, when you allocate an object in Java, they will be close to each other. So it will work, as a cache will work better than if you go everywhere in memories. So it's the problem of benchmark. Usually you are benching not a real application, but a small application, and you don't see the memory effect of it. We have some dependencies. So we have a lot of use cases. I don't know if you know the project Panama. The main goal of the project Panama is to heal the rift between Java and C, hence the name Panama, which is. So in Panama, we want to introduce a vector API to have access to vex instruction in Intel, and I think it's Neon on ARM. Obviously, for that, objects that represent a vector of value should not be allocated on heap. And there is another API which is part of Panama, which is a way to allocate some memory in Java and handle the memory to C. So the initialization part is done in C, but you can access to the object from Java. For that, we need a type-safe representation of pointer, slice of C arrays and things like this. Again, we don't want this kind of object to be allocated on heap. There is another project called Ember. The main goal of this project is to introduce pattern matching in Java. So being able to say, if this object is a rectangle, I will want to extract the upper left point and the lower right point, and I'm interested only in the x part of this point and the y part of this point. You can do this kind of things by destructuring during pattern matching, but for that you need an object that stores the intermediate representation, because you can start to match, say, oh, it's a rectangle, the first point is a point, but the second one is not a point, it's null. So I will not match the pattern. But at that point, you have already started to extract the information from the first point. So you need an intermediary object, and we don't want this object to be allocated on heap, because it means that every time there will be a switch somewhere, you will have some allocation, and it's not a good idea to have this, apart if you use scalar, which has exactly this bug. So here is the roadmap. We have first done a first prototype named MVT. I will explain exactly what the MVT was and what was the shortcomings. So I think last year or last year and a half, we have started a new prototype named L-World. I will explain why. And currently, this is the second iteration of this prototype. You can download it on the early access build on jdk.java.net, and you can play with it. By default, Valhalla is enabled. You don't have to put any flags. It will work automatically. We are aiming to a preview release inside the JDK. We call it L-World 10. We will try to rush to have something like this. What we need to add is currently the support of generics, erased generics, the generics we know. At the end, where we want to be is to be able to retrofit primitive types to be inline types, so to have only two kinds of objects, inline and indirect type. So you will be able to call dot equals on free, it will work. And the other thing is we want to have a new kind of generics, specialized generics that works like C++ template, because currently if you create an array list of complex, an array list of an inlining class, it's still an array of objects, so you will not have the performance of an array of complex. We need to be able to propagate that what we want is create an array of complex and not an array of object at runtime. And obviously we want to be backward compatible, otherwise it will be the project will have finished a long time ago. So we will have to introduce specialized generics in a way which is backward compatible with erased generics. We spend a lot of time figuring out how to do this. I mean, even if it's not in the prototype, we have some ideas how to do it. So the first prototype, the minimum value type prototype, basically you have all your indirect objects, objects you are using currently, and we have introduced a new hierarchy with Java long value being the top type, and so complex and inbox are subtypes of this value. And if you want to have an object, you have to box things. It's really like value type are like primitive types. So complex is a kind of primitive types, and if you want to put it in an object, you have to box it. The only difference is that the box is provided by the VM and not written in code. Very good perf if you use only inlining class, no regression in the code because it's fully separated, but doesn't work well in reality in application because you have to do boxing. Even calling println require boxing, which is a kind of stupid. So, next prototype, L-word. The idea of L-word is that Java long object is the root of everything. It's the root of indirect object and inline object. Technically, object works like a kind of interface. So for every an interface can be an inline class or an indirect class too, like my example with Java long chart sequence. This is a far better model from the user point of view. It's a far worse model from a VM engineer point of view, because now when you have an object, you can have a pointer or not. Oops. How it works? It's simple. If you have a complex, you can put a complex into an object. It just works. And if you have an object and you want to see as a complex, as an inline class, you just cast. But the cast is a little different because you have to do a null check before the cast. Because an object can be null, but an inline class cannot be null. So you can have now a cast that will throw a null pointer exception. So now I will talk about how it works internally, and I will start with the bytecode representation. It's a hardcore talk, yes? I can. So first problem, I don't know if you know this, but if I have this code with a class holder, another class, and a static method that return an order, and it appears that at runtime this holder is null. If you execute this code, the class holder will never be loaded. In Java, the class loading is push to the point where you have no other choice than loading it. If you can avoid to loading it, you will not load it. This is a big issue for inline class, because for an inline class, you want to load it early to know the memory layout. Why you want to know the memory layout early? It's because when you have a method that takes an inline class, you want to explode it and pass only the value of the inline class and not the inline class itself, which means that when you see a method, you need to know the structure of the inline class. And the only way to know the structure of the inline class is to load it. Because if you take a look to the code, you just use a class. You have to load it to see, oh, it's an inline class. So we want to be able to do this. We want to be able to have the method calling convention that explode an inline class, which means that we can have scalarization even if we don't have inlining. The other thing is you have a bytecode verifier, and the bytecode verifier should refuse a code that stores null inside an inline class. So again, it means that the verifier need to know and need to load the class earlier. Which means that inside the bytecode, we need to have two kinds of class, the indirect class, the classical class, and the inline class, and we need to have a way to distinguish between them, because we need to load the inline class earlier than the classical class. So I don't know if you know, but inside the bytecode, we use the prefix L for the reference class. So we have now a new prefix called Q for the inline class. Why Q? Because we need a way to qualify the inline class, so Q. So if I take my int box, it's exactly the same code. If I take a look to the signature of the method 0, the descriptor will be, I will take no parameter and return a Q int box. So it's not backward compatible to take an direct class and put inline in front of it, because the generated bytecode is different. Everybody agree about that? Yeah. Another issue, I don't know if you know, but your immutable class are not immutable. If you are right in the middle of the constructor, you can see the fields are changing from 0 or null to the value you assign. So right in the middle of the constructor, your immutable class is not immutable at all. Oops. So we need a way to avoid that for inline class. The only way is to not have a constructor, because a constructor, when a constructor is called, the memory is already allocated, filled with a bunch of zeros, so it's already too late. So the idea is, when you will write a constructor as a user of the model, but the compiler will transform your constructor to a static factory. So in the static factory, we will be able to be sure that the inline object is always immutable. How we do this? We introduced two new bytecodes. One is called default values, the other is with field. What default value does is returning a new value with every field initialized with 0, and what with field does is not, it will initialize one field, but not of the object. It will create a new one with the field initialized. So the objects are still immutable. So basically, here is the bytecode for my constructor, which is a static factory. I don't know if you know, but constructor inside the bytecode are called init in angle bracket. So now we have static factory init using angle bracket. So we take an int, return the inline class int box. It will first initialize with default value all the values. Currently there is only one. To 0, it stores it at the local variable 1. You can see that the bytecode is not fully optimized. You have a swap in the middle. You load two things and you swap them. It's better to load them in the other order. And so basically you have a with field. So you create an empty object and then you create a new object with the value inside it. So it's fully immutable. Again, it means that even if you write the same constructor as usual, in terms of bytecode, it's not binary compatible. So the source code is mostly the same. You just put inline in front of it, but in terms of bytecode, it's fully different. The references are different. They are Q object, not L object. And inside the class, we use factories and not constructors. So no binary backward compatibility if we don't teach the VM to do the backward compatibility. We will introduce a new notation because the opcode default value can be interesting. So basically, if you do intbox.default, the generated bytecode is default value with the value. So it will create an inbox with all the fields initialized to 0. So inline class and concurrency. We have small issues, which is a value type can be big, bigger than the most wide load and store size of the CPU, which means that when you load a value type or when you store a value type for the CPU, it will be several load or several store. Here is an example. I have an inline class value with two longs, x and y. I have an object that contains that value, and I will just change it. So I have two values, 0 and 1, and I create two threads, one that stores 0 and another that stores 1, and my main thread will take the value from shared and ensure that x and y are the same. It should always work. Yes? No? Okay. Here is exactly the same code. Instead of using inline, I will use an annotation, which is just here for testing. So the main thing is that you can run the code with the current JDK. And if you run it, run it, you will see that there is no assertion. But if I run it, so I will use my build tool to. Why not? So it just compiles the whole things. Well, I have some examples, so it takes some time. And package it, and if I run exactly the same example, I have the assertion error directly. If I change my ints here to be my long, here to be ints instead, I recompile. I run the test, and so on. I have no assertion anymore. Why that? Here, when you do the equals, box.share equals 0, you will store all the values. If you are using ints, if the fields are ints, the VM will emit only one instruction that copy both fields in one instruction. So you have no way, it will be an atomic operation. But if they are longs, the VM will not use 128 store instruction, and so it will be two stores, and you can be descheduled in between the two stores. It's not a real issue because you are doing concurrency wrong here. You have two threads that access to the same field, and you have no synchronize, no volatile or something like this. So The user is definitely doing something wrong, but it will appear in your code. So it's not a new problem. If you use 32 bits VM, you have exactly the same problem with longs and double currently, but nobody uses a 32 bits VM anymore. Some Raspberry Pi, some Android still use 32 bits, but not a lot. So the real solution is don't do that. Don't do unprotected concurrent access at all. So what we need to solve to go to the first release of value types. The first issue we have is that now an array of objects is not an array of pointer anymore, because it can be an array of the value directly, which means that for the VM or for the JIT, it's not an array of pointer anymore. So you have to add more code to check if it's an array of inline type or an array of pointer, which means we will have regression in terms of performance. The current solution is to teach the JIT to not do the check of which kind of array is inside the loop but outside and things like this, to avoid and to have each time you store something in an array of object to have to do a check if it's an array of object or an array of inline class. But clearly it means that a code that will compile currently with the current version of Java may run slow, maybe slower with the current version of Valhalla, because now an object can be an inline class or a pointer. Because now all inline class are subtype of object, it means you can synchronize on it, you can wait and notify on it, you can call system.identity hashcode on it. Basically everything you can do on an object that use the object header usually. So for synchronize, it's like doing synchronize on int. It makes no sense. So you will get an illegal monitor state exception. Same for wait and notify. For identity hashcode, we are not sure exactly what we should do. Currently, it's called hashcode. The worst problem is with equals equals. It's not the equals equals of primitive, it's the equals equals of object. Because when you have an object, it can be a pointer or an inline object. So when you do equals equals between pointer, it's easy, you compare the pointer. But if it's equals equals between two inline object, what you should do? There is no pointer. That's the whole point of an inline object. So we have three possible semantics. Always return false, saying there is no pointer. So equals equals doesn't work. Don't use equals equals. We can do a class check and a component check, basically testing that all fields are equals. Yeah, but it means that equals equals is not fast anymore. It's worse, it can be recursive, because in one field you can have an inline object and so on. So you can have a Stack Overflow. and it can be really slow. The last solution is to redirect equals equals to dot equals. We still have not we're still pondering of what is the best solution for this thing. Currently, the current prototype does the second things. It will do the class check and so on. So you can see that you will have regression when you use equals equals somewhere on object. But you never use equals equals on object. You call dot equals. Yes? You will not add a branch that do equals equals in front of dot equals, because you know that the more branch you have, the more your code is slow. Yes, you know this kind of thing. And the problem with erased generics. Inside a generic class, a T is nullable. Oops. So we can't write a list of complex, because a complex is not nullable. So we have the problem with a map.get. If I have a map of string to complex and I call map.get, the contract of map.get is return null. But because generics are erased, the compiler will insert a cast to complex before your null check, so it will raise a null pointer exception before you are able to test that the result is null or not. So currently, erased generics doesn't work. You will have spurious null pointer at some point in the code somewhere. So we want to introduce a kind of box, like you do with primitive types, but we want a kind of lightweight box. There is a way to do a lightweight box currently, which is if you use an interface to in front of an inline class, basically you have an inline class which is mutable, because an interface, you can always store null inside an interface. So the idea is we will have a complex dot box class generated by the compiler. So you will not be able to use a list of complex or a map of string complex, but you will be able to write a map of string complex dot box. And you will have autoboxing between complex and complex box. And it works that way. This is what you write when you write a complex inline class. And this is what the compiler add. It will add a new class, a new interface, named box in lowercase. And the complex will implement complex.box. It's just an interface, there is no method in it. The idea is you need a way to represent a nullable inline object. I don't know if you know the sealed and the permits keyword, but these keywords will be introduced in Java 14. Sealed means this interface has a list of permitted subtypes, and permits list the subtypes, and here the only subtypes possible is complex, which means that you cannot create a class that implements box. The only permitted class implemented box is complex, which means that from the JIT point of view, you know that this interface have only one class, which is an inline class, so you can optimize. So, to summarize, I have no idea where I am in terms of timing, but This is the current roadmap. We are right in the middle. We are trying to go to the preview release as fast as we can. As we have seen, we still have some struggle about what to do with equals equals. It will be a preview release, which means that you will have to use -- enable preview to use it, and it will stay a preview release for a long time. Obviously, at the end, when we will be all dead, we will have specialized generics. So, what will be what an inline class for the preview release? Something with no identity, not mutable, not nullable, and tirable. Oops. Don't use unprotected concurrent access. The runtime will be the value is scalarized into register, and on heap the class is inline inside the containing class. Object will be the root of everything, so all the code that use objects like serialization, JSON, marshalling, and things like this works automatically, which means there may be some regression in terms of performance, but we have some really great VM engineers that will solve this using a magic wand. Don't use equals equals in your code on object now. It will be worse. Don't use it. Start to reprogram yourself. Reprogram your brain. Equals equals doesn't exist. Yes. And it will support erased generics using lightweight boxing, using interfaces. That's all. Do you have questions?
Who have a question?
Yeah, you're saying you can't extend classes. Can you still use default and interface methods?
Yes.
Okay.
Yes. Maybe in the future you will be able to extend things. The main issue with extending things is you have the cascade of constructor, and we have seen that you cannot use a constructor. That's the main issue.
So my question is exactly about constructor. So if I still write in my source code a constructor, so what will happen if I try to escape this?
If you try to
escape this, I will try to pass this somewhere.
Oh, yes, if you try to escape this, it doesn't compile. And you should not do that in your constructor currently, because you are escaping an object which is not fully initialized. And if you take a look to the Java memory model, by example, there is no guarantee on this this which is not fully initialized. You have guarantee when you are outside of the constructor that final fields are initialized, by example. But there is no guarantee at all if you start to use this inside the constructor and send it to someone. Don't do that. Even currently, don't do that. You are shooting yourself in the foot if you're doing this.
Hi, thanks for a great talk. I have a question. As Valhalla is inline class, they are immutable, so the hash code is immutable too?
Yes.
Yeah, that's the question in case of equals, and can we use hash code in equals comparison? Maybe you've already said.
Currently what we do is basically what will be in Java 14 for records. We automatically generate equals hashcode and toString for you if you don't provide them. So you have the right one.
Okay. Okay, thanks.
Hi, thank you very much for the pitch. It was very helpful. I have a question about garbage collecting. So how garbage collecting is looking on the inline object since there is no pointer, as you said?
It depends. It depends. If you are using it on the stack, basically there are value on the stack. So the inline object doesn't exist at runtime. That's basically the idea. What only exists is all the value inside it. But the wrapper itself doesn't exist. So for the GC see all the component. It doesn't see the wrapper. So there is no issue. And if you are on the heap, it's exactly the same thing. You take all the field of your inline object and you put it in the container object. So again, the GC doesn't see the inline object at all. Okay, so if the parent object is collected, inline objects will be automatically collected. Exactly. Okay, thank you.
Thank you for the talk. And my question is, while we have immutable objects from the from the view of Java semantics, I believe that many applications will need some kind of optimizations when we will replace the whole object in hope to replace one field of one component of an inline object. Do you expect that the JIT will be effective in discovering that just one component is changed and when replaced will be converted to small modification just of the modified field? So you are talking about the opcode with field. Currently the JIT already do these kind of things. If you have an empty object and you call with field, that create a new one, and with field, and with field, and with field. No. So the JIT does this. I suppose I get the element of the array, modify with view field just one component, and storing back. I expect that JIT will discover what one field is changed. Yes, don't need the whole compare. Yeah, it's a good question, but I have no idea if this is done currently. But okay. Yes, it will be done. Okay, thank you.
The last question, please.
What is going to happen with Java-lang integer?
Very good question. It's obvious for what we have done currently is deprecated new integer. I don't know if you have taken a look, but in a recent release, if you do a new integer, you will get a deprecation warning saying, don't do that anymore. So currently, I have written a small prototype that just changed Java-lang integer to an inline class. You just pass the class and run things like Maven, Gradle, and things like this on my software, and it doesn't work.
Yeah, but integer extends number, and inline classes cannot extend anything.
Yeah, but I have removed the extends number. Okay. The problem was not a class cast exception because of number. The problem was some people think that doing equals on an integer is a good idea.
Okay, so you're not aware of any plans regarding Java-lang integer in the future releases?
So basically, I think we have two ideas. two ways to dealing with this. The first one is what I will call the purge. The idea is you kill everybody that use equals on integer, and you delete all the code that do that. The other solution is what Graal does. Basically, what Graal does is to tag how integer was created. If it was created using new, or if it was created using integer.valueOf, you will have the same data structure, but a bit is set or not. And basically, depending on this bit, it will be like an inline class or not. But it will be a lot of work.